Hi everyone, if you want to revise the whole of integration, mastering with all the type of questions, you are in the right place. And this video series will help you to achieve that. Check it out. Hi everyone, this is our 7th video tutorial in the topic of integration. In this topic, we are going to learn about reverse chain rule. How to use the reverse chain rule technique to do the integration type of question. In this reverse chain rule, we have two types of question. The first type is our pattern 19. When the integration question comes, there is a u over v pattern, u over v pattern dx. All what you want to do is you need to check the v function, which is the denominator function, that denominator's differentiation, it's going to become on the top as u, right? So this is a simple checkup you need to check before you attempt to do the integration. So all what you want to do is take the denominator function and do a normal differentiation. You can do the working out or you can do it mentally, just to mental maths, just to do it in your head and see whether the differentiation's result is coming as a numerator function, the top function as a u, right? If it does, this is the pattern. So that answer is going to be ln of the v function, right? You may need to adjust the constant in a way to make sure the answer is correct. I'm not too bothered about that one. When we are doing the question, I will explain that is clear, right? So with this one plus definitely C. Before I started to explain the second pattern, we will try to get familiar with the first pattern. What is the reverse chain rule and how to apply that in the integration? First of all, I'm going to be differentiate ln 2x squared plus 5. I'm just going to be take this question as a kind of a example. When you do the differentiation dy over dx, what is the differentiation of ln x? So ln function is 1 over that function 2x squared plus 5. Then chain rule, you need to differentiate the 2x squared plus 5, which is 4x. So the answer from the differentiation is 4x over 2x squared plus 5. Now, we know actually differentiation's opposite operation is integration. So the result is 4x over 2x squared plus 5. When you integrate with respect to dx, the answer will be ln 2x squared plus 5 plus c. That is the technique we are going to do, right? I'm going to be explaining a couple of questions, almost like a first 6 question we are going to do in that pattern. And after that, everyone familiar with the first 6 patterns, then I will teach you the second equation of the reverse chain rule. The first one, question number 1, integrating 2x over x squared plus 4 dx. For a start, I'm going to take the denominator function. So denominator function is x squared plus 4. If you differentiate this function, it's going to be 2x. That 2x is, the 2x is coming on the top. So the pattern is exactly the 19th pattern. So the answer is ln x squared plus 4 plus c. When we are writing the ln function, we always advise to write as a modulus function. So because ln cannot take any negative numbers, so you need to write 2 parallel lines and the functions in the middle. So that means modulus of any function is the ln function. So ln cannot take the negative number. So that is the answer for question number 1. Let's move on to the question number 2. So question number 2 is Q2 integrating 5x over x squared plus 4 dx. Now I'm going to take the bottom function x squared plus 4. This one's differentiation is 2x. However, there is 5x there. So I'm going to make this question into a format what we prefer. Take the 5 outside. Take the 5 outside. I have x over x squared plus 4 dx. Now carefully understand what I'm going to be, how I am going to be explaining. I'm changing the color to a different color to show the difference. So when I differentiate the bottom function, means the denominator function, I got 2x. So the top function has to be 2x. So I am going to write the 2x here, right? To cancel the 2, I'm going to divide by 2. So mathematically, I didn't do anything wrong. So I'm timesing by 2, dividing by 2. So both are same. So now 5 over 2, leave that as it is. Now the answer is ln x squared plus 4 plus c. Done. So the question is done. So you need to make sure, change the question into a format that bottom one's differentiation coming on the top, then you write as a ln function. That is the technique we are going to do in the reverse chain rule. Now question number 2 is done. Now question number 3. So question number 3, integrating cos x over 3 plus 2 sin x dx. Now take the bottom function, which is the 3 plus 2 sin x. Now carefully differentiate. 3 differentiation is 0. 2 sin x differentiation is, differentiating sin x is cos x. So 2 cos x, right? So now I am going to take the function exactly correct. Now I'm going to use let me write the question. So I'm writing the question again as it is, cos x over 3 plus 2 sin x dx. To explain a little bit better, I'm using a different color to bring the 2 on the top. Why I'm bringing the 2 top? Because the denominator's differentiation has to be on the top function. To cancel the 2, I'm going to write half in the front of the integration. Mathematically, half and 2 cancels off. So the answer is half ln 3 plus 2 sin x plus c. Now question number 3, done. So let's do the question number 4. So question number 4, Q4, is integrating e to the power 2x and divided by integrating 2x plus 1 dx. So take the bottom function, which is e to the power 2x plus 1. If you differentiate, this is going to be 2e to the power 2x. Now I'm going to make up the question with 2e to the power 2x over e to the power 2x plus 1. Now you need to be very careful with the 2. So I need to write half in the front, so that 2 cancels off. So the answer is half ln modulus of e to the power 2x plus 1 plus c. Now that is the answer for question number 4. Now let's move on to the question number 5. Question number 5 is integrating cot x dx. I'm going to change this question into cot x equal cos x over sin x dx. Now bottom one, the denominator's differentiation sin x, if you differentiate the sin x is cos x, it's coming as a top. So the answer is ln sin x plus c. That is the answer. Let me do the question number 6 as well. Question number 6 is integrating tan x dx. Now you change the tan x is sin x over cos x dx. Now cos x differentiation is minus sin x. So I am going to be bringing a sign with a minus element to make mathematically correct. I'm going to put another minus outside of the integration because that two minuses makes plus. I am purposely putting a minus inside because when you differentiate the bottom function, it is minus sin x. So the answer is minus ln of cos x. Now the minus considered as minus 1, that minus 1 can go as a power as a ln cos minus 1 ln cos x to the power minus 1 plus c. Further in maths, cos inverse function is sec. So 1 over cos is sec. So you can write ln sec x plus c. That is the question number 6 done. So this is the technique we are going to do for the reverse chain rule. So reverse chain rule, we have completed the pattern 1. So now we are going to move on to the pattern 2. So pattern 2 of the reverse chain rule, it's the 20th pattern, integrating f dash x and the fx to the power n dx. This is the pattern we are going to do. So in this pattern, when you see a question, you can see the two functions are uv format, u times v. Two functions are multiplied together, not divide. If it is divide, you need to check the reverse chain rule, first pattern. If it is multiply, it could be the reverse chain rule, second pattern. Now what you need to do is, one of the function with the power, you need to take that function and increase its power. So fx increase its power as n plus 1. So the function is n in the question. I increased the power by 1 and assign that as a y. Let me change the color and show the like a little bit of working to explain this work. The one I am colored in a pink color, it is additional work I am doing in order to understand the question. So I take the y function as a fx to the power n plus 1. I increase the power by 1. So now I am differentiating dy by dx, which is n plus 1 in the front, fx to the power, differentiating n plus 1, take away 1 is n, then fx differentiation is f dash x. Now this is the pattern you are having in the question. So f dash x and fx to the power n are multiplied together. Don't worry about the n plus 1 and all the coefficient. The coefficient, the number, the k value, we can adjust when you doing the question, right? So don't worry about the n plus 1 at the moment. You need to understand the power, the function with the power increased by 1, you differentiate and you get a function. So that function and the differentiated functions are multiplied together. Let me show you an example, then you can understand this is a bit better. So theory with fx, maybe sometimes you won't be able to understand what is happening. Let's do the question number 7. Question number 7, I'll try to explain this slowly. So integrating x function and x squared plus 5 to the power 3 dx. Now this function, I'm going to do a test. The function with the power, I take it and write it as y, x squared plus 5 to the power 4. Why I'm increasing the power by 1? Now differentiate the function dy by dx, 4 coming to the front. Now x squared plus 5, 3, when you're differentiating n minus 1, 4 minus 1 is 3. Now you need to differentiate the inner function x squared plus 5, differentiation is 2x. Now I multiply this one, is going to be 8x x squared plus 5 to the power 3, that is the dy by dx. Now if you integrate the 8x x squared plus 5 to the power 3 with respect to dx, that gives the original function x squared plus 5 to the power 4. That is the rule I am using in the reverse chain rule. So now what we are going to do, I need the 8x and this one. So this function is there, this function is there, here x is there, x squared plus 5 to the power 3 is there. Only thing is not there is 8. So I can introduce the 8, mathematically make it correct, and I am going to be put 1 over 8 in the front. So the answer straight away 1/8 x squared plus 5 to the power 4 plus c. When you understand and identify this is the pattern, then you can write the answer straight away. That is question number 7. So after the question number 7, let's do the question number 8. Let me clear this one. Right. So question number 8, if you carefully look at that one, so integrating 3 cos x sine squared x dx. Now I'm going to do some little bit work. So I'm taking the function with the power as y. So y equal sine, increase the power, sine cube x, and differentiate dy over dx. It's going to be 3 sine squared x. Differentiating the sine x function is cos x. Now check this function with the question. So in the question, sine squared x is there, cos x is there, and 3 is there. So everything is there. So you need to write equal sign, and the answer is fx to the power cube. So that is sine cube x plus c. That is the answer. So the answer, writing the answer is very easy, but identify this is a reverse chain rule pattern 2. You need to familiar with the pattern. Let's focus on the question number 9 now. Question number 9, it is a tricky one. Let me check. Integration sine 2x over 3 plus cos 2x cube dx. Now, if this is coming in your exam, you wouldn't know this is a reverse chain rule 1 or reverse chain rule 2. So you need to do some little bit of testing to see whether which pattern it's going to be falling to. So let's do the first pattern. So first pattern, reverse chain rule, pattern number 19, what we studied, the bottom one's differentiation. The bottom one with the power. So bottom one's differentiation, if you take the bottom one as a y equal 3 plus cos 2x to the power 3, this differentiation is dy by dx is 3 plus cos 2x to the power 2 times by cos x differentiation is minus sine 2x, and then times by 2. All these functions are not coming in the top. So definitely 100% sure this is not the pattern 1. So this is not the pattern 1. So we can't do the reverse chain rule pattern 1 formula. So pattern 2, the functions has to be next to each other, isn't it? So now with our algebra knowledge, we can write the sine 2x, and sine 2x is the first function, times by, you can write the 3 plus cos 2x next to it with the negative power. With the negative power, you can write now. Now you do the, let me change the color to a different color. Now I am going to be taking the function with the power as my y function, y equal 3 plus cos 2x to the power minus 3. And now I am going to differentiate this one. Dy by dx is minus 3 coming to the front, minus 3 plus cos 2x minus, now I forgot to add 1, so that is the biggest mistake. You shouldn't be doing that one. So let me add 1 to the power. Minus 3, you need to add 1, which is minus 2. Now differentiate. Dy by dx is equal to minus 2, 3 plus cos 2x. Now when you take away 1, that comes to minus 3, right? And times by, inside the bracket you got 3 plus cos 2x, you differentiate that one, that is minus 2 sine 2x, minus 2 sine 2x, right? Now check this one with your question. So this is exactly there and sine 2x is exactly there. Only thing missing is this minus 2 times minus 2 is positive 4. So I need to introduce a positive 4 inside sine 2x, then 3 plus cos 2x minus 3 dx. And now to mathematically make it correct, I am writing this 1 over 4, and that is the answer, 1 over 4. Now you need to write the answer what you got. So that is 3 plus cos 2x. This is the answer, because here to here is differentiation. If you go backwards, that is integration. So that's to the power minus 2 plus c. And that is the answer for the question number 9. And we are moving on to the last question. Question number 10. Let's do this one. So trying to identify both of them having the power sine squared and tan squared. So let me write that one clearly. So number 10, integrating sec squared x tan squared x dx. Now both of them are having the power. So I'm going to take one of them for a try and see it's working or not. So I'm going to take y equal sec. Now increase the power. 2 plus 1 is cube x. Now differentiate dy by dx equal 3 comes on the front, 3 sec squared x. Now differentiating the sec x is sec x tan x. So sec x tan x. Now the answer will be 3 sec cube x tan x. That answer is not there. So my assumption is wrong. So now I'm going to be change my y formula. So I'm going to be reverse all what I did, and I'm going to take this time y as a tan cube x, y as a tan squared is there. So I'm increasing power tan cube x. Now differentiate dy by dx. That is going to be 3 tan, take away 1, so 3 tan squared x. Tan x differentiation is sec squared x. That sec squared tan squared exactly matching. Only thing I need to make up the question with 3. So integration of 3 to mathematically make it correct, 1 over 3 in the front. Write the question again, sec squared tan squared dx. Now you can straight away write 1/3 tan cube x is the answer plus c. And that is the answer for question number 10. Hope you understand this one. If any of the questions you couldn't understand and you need some more explanation, please do comment below, and I will make sure that I will release another video to explain the question, or if possible I can explain in the comment section also. And we have few more tutorials to complete this integration topic, and tutorial 8, 9, 10, it's very important. Subscribe to us and just please connect to us to revise this video tutorial. See you. Bye.